Good morning, everyone. I am Balaji, Assistant Professor, Shriram Engineering College. Today, I am going to present the topic Electrostatics. Electrostatics is an important fundamental concept in electrical and electronics engineering. It deals with electrical charges at rest, the forces between charges, and their interaction with materials. By the end of this presentation, we should be able to understand and classify electrical charges and analyze how charges interact with matter. We will also understand the basic rules governing the attraction and repulsion of charges and the force acting between charged objects. Let us begin with historical background. The study of electricity goes back to approximately 600 BC. The Greek philosopher Thales of Miletus observed that when amber was rubbed with wool, it could attract small objects. This simple observation was one of the earliest recorded observations of static electric charge. Later, Benjamin Franklin made important contributions to the understanding of electricity. In 1752, his famous investigations helped establish the connection between lightning and electric charge. His work played an important role in developing our understanding of electrical phenomena. During the 1800s, electrical science developed rapidly. Michael Faraday in 1831 demonstrated electromagnetic induction. He showed that moving a magnet through a coil could produce an electric current. Although electromagnetic induction belongs more directly to electromagnetism, Faraday's work was an important milestone in the development of electrical engineering. Now let us understand the main topic, electrostatics. Electrostatics is the study of electricity at rest. It involves electrical charges, the forces between charges, and the behavior of charges in different materials. A simple everyday example is the small electric shock or attraction we sometimes experience after walking on a synthetic carpet and touching a metal object. To understand electric charge, we first need to understand the basic particles of an atom. There are three important particles. Number 1, electrons. Number 2, protons. Number 3, neutrons. Electrons has negative charge, proton has positive charge, and the neutron has no electric charge. The movement of transfer of electrons is responsible for many electrical phenomena. An atom consists of positively charged nucleus surrounded by negatively charged electrons. The nucleus contains protons and neutrons, while electrons occupy the region surrounding the nucleus. An important point is that all electrons are identically carry the same magnitude of negative charge. The nucleus is composed of protons and neutrons. Protons are positively charged, whereas neutrons have no net charge. Normally, an atom contains an equal number of protons and electrons. Therefore, its net charge is 0. The most fundamental rule of electrostatic is like charges repel each other and unlike charges attract each other. Electric charge. Electric charge is measured in coulombs. It represented by the symbol capital C. Charge is also quantized, which means charge exists in integral multiple of elementary charge. This is given by charge small q equal to n into small e, where small n is an integer and small e is the elementary charge. The constant value of elementary charge is approximately 1.602 into 10 power minus 19 coulomb. Another important principle is that electrical charge is conserved in an isolated system. Now we come to one of the most important laws in electrostatics, that is Coulomb's law. Coulomb's law explains the electrical force between two charged objects. It is similar in form to Newton's law of gravitation, and it follows an inverse square relationship with the distance. The law was established by French physicist Charles Coulomb. Next, statement of Coulomb's law. It states that the force of attraction or repulsion is directly proportional to product of two charges and inversely proportional to square of the distance between them. The Coulomb's law equation is capital F equal to small k into small q1 multiplied by small q2 divided by r square. Here capital F is the electric force, small 1 and small q1 and small q2 are the two charges, and small r is the distance between them, and small k is the Coulomb's proportionality constant. Therefore, if the charge increases, the force is also increases. If the distance increases, the force decreases rapidly because of the square relationship. Next, Coulomb's law and Newton's law of gravitation have similar inverse square form. However, there is an important difference. Gravitational force between masses is always attractive, whereas the electric force can be either attractive or repulsive, depending on the signs of the charges. This makes electrical interactions particularly important in electrical and electronic systems. The SI unit of charge is Coulomb. 1 Coulomb corresponds to approximately 6.24 × 10^18 elementary charges. This gives us an idea of how extremely small the charge carried by an individual electron is compared with 1 Coulomb. The proportionality constant in Coulomb's law is represented by small k. Its value is 9 × 10⁹ Newton per meter square per Coulomb square. This is a very large value which indicates that electrical forces can be extremely strong compared with gravitational forces. Thank you one and all.